welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace, as usual. In this video session, we shall discuss another application of piecewise functions. In the other video, we did water bill. We did a water bill by Calhoun County Water Authority, State of Alabama, United States of America. In this video, we are going to do power bill, and this power bill is from Georgia Power, State of Georgia, United States of America. So, if you go to Georgia Power, you're going to see the power bill. Okay, we are going to do residential rates, and we're going to do the summer residential rates. However, I want to inform you, okay? If you go to my website here, www.piecewise-functions.appspot.com, you will see the power bill from Georgia Power website, the website of Georgia Power. So I copied it from their website, and I solved it. I developed a calculator for it, and of course, when you do this for my students, you have to do it two methods. The manual method, the first method is manual method, and the second method is piecewise function method, so that you can appreciate this topic. So I I went to their website, so I copied it, I did it myself, I developed the calculator for it, and I looked at the interactive sample bill. There is an interactive sample bill on their website. Okay, so I clicked on the interactive sample bill. It is not interactive. And please, Georgia Power, please, I am not trying to say anything negative now. I'm not. However, it's just what, I put this on my website. It would be good if you fix it on your website. Okay, it would be good if you do that. So I am not trying to make any enemies at all, no. So please, because if you have a student who is working on a project, doing research, comparing power bills of different states, and the person goes to Georgia Power website, and then it doesn't have the correct information, that messes things up, So anyway, the sample bill is not interactive. It says interactive sample bill. It is not interactive. Okay. So, and then I checked the kilowatt hour. Okay, the amount of power that was consumed. Power is in the SI unit for power is joules. Okay, but you can also measure it in kilowatt hour. That is what the United States measures power in. However, the SI unit, the System International Unit for power, is the joules. Okay, but it's measured here in the US in kilowatts hour, kWh. Okay, so I checked the amount of power consumed, checked it with my calculator, it didn't work. So somebody must be wrong. Either I am wrong or they are wrong. So okay, hey, so guess what? I contacted Georgia Power and they said, hey, this is just a sample. Okay, this is a sample. It doesn't mean it's right. It's a sample. Okay, this is the actual website to get the correct information. So I appreciate the person from Georgia Power that gave me the actual website to get the correct information. And that is from, the actual website is from Georgia Public Service Commission. Okay, Georgia Public Service Commission. So, come on, Mr. Steve, you should be teaching this and you're telling stories. Don't you like story? Okay. So I went there and I saw, oh, wow, these people developed a calculator for this. That's great. Okay, so that's great. They even developed a calculator for it. That's good. Because that is the essence of this. Trying to teach students the concept in mathematics. You know, you do it arithmetic, manually, manual method. Then you say, hey, okay, this is too, what if you have so many bills to compute? You have so many customers. You can't do it manually. You've got to develop a piecewise function for it. And then one of the advantages of the piecewise function is that from there you can give it to the computer programmer, or you teach students and they develop the computer program for it. You know, you can do it with Python, you can do it with JavaScript, you can do it with Ruby. I mean, several programming languages that students can develop for it. That way they learn. Okay, so I was happy to see that Georgia Public Service Commission has a calculator for this already. So you know what, I checked it with their calculator, and guess what, it was right. You know, now I saw a different. Okay, so I had to rewrite my calculator though. I had to rewrite my calculator. I had to rewrite it because it was a different information. Okay, so I've said this several times. Don't round your answer. Don't round intermediate calculations. Only round the final calculation because it's dollars, so it's 2 decimal places. However, the intermediate calculations do not round it. Okay, so why did I tell you all these stories anyway? All this story, right, is because the information I'm writing here is not from Georgia Power website. It's not. It's from Georgia Public Service Commission website, and that contains the actual information. The one in Georgia Power website is incorrect, or you can say incomplete, but I would say incorrect. Okay, so this is the actual information, right? Information, correct information. Okay, so this is, we have that the basic service. Basic service is $10. That's the basic service. Whether you use it or not, you must pay $10. That's the minimum you will pay. Okay. Then we have the tier. Here we have the usage. Let me make a space. Usage. Then we have the cost per kilowatt hour. Per kilowatt hour. And what I am teaching you now is already on this website. Okay, so when you go to this website, you will see the transcript of what I am teaching you now. Okay, so the first one is, we have the first tier, and this is up to 650 kilowatt hour. and the cost is 0.056582. So you have to write the entire, don't round, no, don't round 5 cents, 5.7 cents. That's what Georgia Power has, 5.7 cents for the summer residential rate. I think they had it as 5.7 cents. No, you don't round, no. Write it as is. Do not round intermediate calculations. No, no. It can mess up the final answer, the final calculation. Okay? And you don't want the company to be losing money. When we did, I stressed, actually I gave examples of this in Mathematics of Finance. If you go to my website, look for Mathematics of Finance. I stressed the importance of not rounding until the intermediate calculations, of not rounding the intermediate calculations. You only round the final answer. I gave if you go to Walmart and you're buying things, before they round your checkout price, they have to add the whole thing, any discount, any tax. They have to write it as is. They don't round intermediate calculations. They write it as is before they now add everything up, and then your checkout price will now be rounded to 2 decimal places. So anything involving money, do not round intermediate calculations. If you view my videos on the Mathematics of Finance, you will see I stressed the importance there. Okay, so that's the thing. Second tier, next 350 kilowatt hour, and this is 0.093983. Then you have the third tier. The third tier, over 1,000 kilowatt hour, and you have 0.097273. Okay. So please, I want you to, you can write, I'm doing for the summer, you can do for the winter. You can also do for other rates, in other types. There are other types of bills that they have. Okay, when you check it with the calculator on Georgia Public Service Commission, if you notice any problem, just let me know. Okay, you can let me know so I can verify, I can cross-check it again. I didn't check it like with a lab, but I checked it with just few examples. I think there was probably one of them that was missing 1 cent. Okay, but this is what I want to say, and I'm not going to, I don't want to get into, I'm not gonna get into anybody, I'm not getting into somebody's way, no. But if you're solving math, if you're taking my class, you miss 1 cent, I take away points. Because if you're missing 1 cent, if let's say Walmart, if they lose 1 cent per customer, okay, let's say Walmart, for example, if they lose 1 cent per customer in a day, do you know how much that would be? Do you know how much that would be? You might say, hey, Mr. C, it's just 1 cent. I know, I'm not stingy. I can lose 1 cent, I don't care. But the thing is, the thing we are teaching you to not to, you lose 1 cent. No, you have to get it correct. So even if it's too much decimal places, use it that way. Do not round. Intermediate calculations, do not. Now the final answer you now round. Now, unless your professor says round, then you round. Otherwise, don't round. No, do not round. Okay. So if you own a company and you lose 1 cent, you have maybe 100,000 customers in a day, and you lose 1 cent per customer. Do you know how much you've lost? So you can check it with a calculator. I checked it with mine, and I don't know if it's 1 cent missing. That's why it's good to also do it manually. Okay, but it should be the exact thing. Should be the exact. You do it manual method, you do it piecewise function method, you should get the same answer. If you don't get the same answer, fix it. Has to be the same answer. Okay, so this is the information on the Georgia Public Service Commission Power Bill calculator. They called it Power Bill calculator. The link is on my website. You will see the link on my website. Okay, now we are going to solve this. As usual, we will test it. We are going to test it. We will do manual method first, then we do piecewise function method, and we are going to check it with both. Okay, so we have here, we're going to test it for arrow of 0, arrow of 300. I am using the same thing I used on this website, so you can see arrow of 700, arrow of 1000, arrow of 1200. Yeah, I want to test it on each piece, for each piece. Okay. All right, so the first thing you want to do is to define your variables. Define the variables. So let's say, let P be the amount of power consumed. Amount of power consumed in kilowatt hour. Kilowatt hour. Kilowatts hour. Kilowatt hour. And let R be the rate of consumption of power. The rate of consumption of power. Power, 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 power. Okay. This is in dollars. Dollars per kilowatt hour. Dollars per kilowatt hour. And that's the rate, cost per kilowatt hour. All right. So if you consume 0, okay. Now, we're gonna do this first method is manual method. Manual method. And I'll call it, I can call it arithmetic. Arithmetic method. Arithmetic method. By arithmetic. Okay? So arrow of 0, we have this, that arrow is a function of P. Arrow is a function of P. If we come to algebra, okay, arrow is the dependent variable and P is the independent variable. The rate, the cost, okay, the rate at which you consume it, cost per kilowatt hour depends on the amount of power you consumed. Okay, the cost per kilowatt hour depends on the amount of power consumed. So R is a function of P. R is the dependent variable and P is the independent variable. So you can also say R of P. You can just write it as R of P. You can. So let us begin with the first question. Arrow of 0. In this case, arrow of 0 means that we want to find the rate of consumption of 0 kilowatt hour of power. The power consumed is 0 kilowatt hour, and we want to find how much. What is the rate of consumption for 0 kilowatt hour? So this means that the power is 0 kilowatt hour. That is what it means. So we first of all we write the basic service, the basic fee. The basic fee is $10. That's the basic fee, $10. Then this is the basic fee regardless of the amount of power consumed. Then we look at the 0 kilowatt hour. Where does it fall? Where does it fall? It falls in the first tier. The first tier is up to 650 kilowatt hour. So we now say 0 kilowatt hour at 0.056582 per kilowatt hour. What will it be? So we multiply that 0 times 0.056582, and that gives us $0. $0. So we now see that the total for arrow of 0 is the $10. The $10, let me just write 10 plus 0, which is just $10. So this gives us $10. Okay. Number 2, we want to find the arrow of 300. The rate, how much will it cost someone? What will be the bill if the person consumed 300 kilowatt hour of power in a month? This means that the power P is 300 kilowatt hour. So we still write the basic fee. The basic fee is $10. You know what? We can write. Let's write, because we are going to. We are doing this manual method, arithmetic method, like we mentioned it. So let's write the cost for each one, because we are going to still do this using the second method, which is the piecewise function method, or algebraic method, if you want to call it algebraic method. So let's write this here. For arrow of 0, this gives us $10. Arrow of 300 is the next one. So we have the basic fee. Then 300 kilowatt hour falls in the first tier. It falls in the first tier. So we now say 300 kilowatt hour at 0.056582 per kilowatt hour. That gives us 300 times 0.056582. And that gives us, I brought my calculator. Okay, so 300 times 0.056582. And this is a 16.9746. So we now add the total fee will be 10 plus 16.9746. So this is plus 10. And that is 26.9746. So you do not round until the final answer. Okay? We do not round intermediate calculations. We only round the final answer. So our 300 will be $26.97. So this will be $26.97. This is the cost. Okay, this is the power bill for someone who consumed 300 kilowatt hour during the summer program. Now this excludes the taxes and the senior discount for seniors and the rest of them. Like, this is the basic that we are doing. Okay, the next one is the rate, the cost for 700 kilowatt hour. The cost for 700 kilowatt hour. So I'm going to do this. Let's erase this here. Rewrite this R700. So this means that the power consumed is 700 kilowatt hour. We have the basic fee, which is $10. Then we now 700, as you can see here, 650. The first tier is up to 650, which means it includes 650. 650 is included in the domain. Now, beyond 650, it falls in the second tier. So, to do this, you have to, first of all, for 700 kilowatt hour, they will charge you, the 650 of it will be charged at this rate. Okay, 650 kilowatt hour will be charged at this rate. Then after that, the remaining, when you do 700 minus 650, that gives you 50 kilowatt hour. That will now fall in the second tier, and then it will be charged at this rate per kilowatt hour. Okay, so we first of all do 650 kilowatt hour at 0.05652 per kilowatt hour. So this is 650 times 0.05652. 650 times 0.05652. And that gives us 36.7783. Okay. Remember, we are doing first method, manual method. Then the remaining, okay, 700 minus 650 is 50 kilowatt hour. So this remaining 50 kilowatt hour will be charged at 0.0, it will now fall in the second tier at 0.093983 per kilowatt hour. And that gives us 50 times 0.093983. So we do 50 times 0.093983. That gives us 4.69915. So we now add everything, 10 plus 36.7783 plus 4.69915, and that is this plus 46.7783, 51.47745. So the cost here will be $51.48. So this is, you do not round intermediate calculations. You only round the final answer. So this is number 3. The rate for 700 kilowatt hour will be, the cost for 700 kilowatt hour is $51.48. Okay. Now the next one, is number 4, rate for 1,000. The cost for 1,000 kilowatt hour. So I'm gonna I will just erase some of these here. Number 4, the cost for 1,000 kilowatt hour. So this will be first of all, we write, in this case, P is 1,000, right? The P is 1,000. Then we write the basic fee. Then we have the 650 first, 650 at this rate, and that gives us 650 times 0.056582. Okay, I think I've been saying rate. This is cost, actually. Is the cost, so you understand what I'm saying. Okay. Now this is actually the rate, the cost per kilowatt hour. I know some people might say, hey, why are you saying rates? Okay. Is the cost per kilowatt, the cost for the whole power. I know I wrote it our rate of consumption, but that's okay. It's still you understand what I mean. Okay, you can say cost per, instead of R, you can say C if you want to. Okay, if you want to, you can say C instead of R. You know what? To be, let's say this, okay, to be very, very exact, okay, to be very, very exact, I'm gonna call this cost. I'm gonna now say cost per kilowatt hour, C. I'm gonna now write it like this. C is a function of C. Okay, let me use C. it's much better. Much better. C, cost for 0 kilowatt hour, cost for this. So I'm going to say C, P is the power consumed, and then C is the cost per kilowatt hour of power consumed. How about it? So cost is a function of the power. Okay, so you can say C of P. Cost is a function of the power, the cost. Yeah. It's much better to use C instead of R. So my bad. I mean, I'm doing this and I'm like, okay, I'm saying rate. You know, rate is usually with time, but that's fine. Let's use cost. Much better. So cost is a function of the cost for the kilowatt hour consumed is a function of how many you consume, how many that was consumed. I'm not saying you as a human being consuming it, because some people will say consuming. Okay, no. It's what you use. That's, you know, we say power consumption. That's the technical term, power consumption. Okay, so let's use C of this, C of that. Okay. Let's use C of that. All right, so I'm going to now use this as C, cost. So cost for 1,000 kilowatt hour will now give us this 650 times this. This is 36.7783. All right, now this is for the second tier. We now do, sorry, this one was for the first tier. We now do 1,000 minus 650, and that is 350 kilowatt hour. 350 kilowatt hour. And this falls in the second tier. Okay. So the thing here is this. You've got to, before you get to the second piece, you must go through the first piece first. That is the idea. Okay. So we now say 350 kilowatt hour will now be charged at that rate. Okay, the rate for the second tier is 0.093983 per kilowatt hour. So this is 0.093983 per kilowatt hour. And that will give us 350 times 0.093983. 350 times 0.093983. So this is 32.89405. Okay, so we now add everything. 10 plus 36.7783 plus 32.89405. That gives us what? This is plus 36.7783 plus 10. So that gives us 79.67235. So the cost for 1,000 kilowatt hour of power consumption is $79.67. So the cost for 1,000 will be $79.67. Okay. The last one for our manual method. Cost for 1200. Cost for 1200 kilowatt hour. Okay, I'm gonna I'm looking for what to erase. Let me not erase everything. Okay, so cost for 1200 excuse me, kilowatt hour. Here the power is 1200 kilowatt hour. So we have the basic fee, then we have 650, okay? We have 650 gone. Then after this 650, we get this, right? So the next 350, we don't need to write 1200 minus 650 because we already know like this 1200 falls in the third tier. It falls in the third tier. So we do 350 kilowatt hour, 350 kilowatt hour at this. So this will be equal to 350 times this. And that gives us 32.89405. So now you do, okay, now you do 1200 minus 1000. I mean, I know some people might say, okay, why don't you do 1200 minus 650, okay, and then you now do 1200 minus 1000. It's still okay if you want to do that. Some people will say, do this 1200 minus 650, and you have 550 kilowatt hour. Then of this 550 kilowatt hour, the 350 would be charged at this rate. Just 350 out of that 550 will be charged at that rate. After that, what is remaining, you now do 550 minus 350, and that is 200 kilowatt hour. So the remaining 200 kilowatt hour will be charged at the rates for the third tier. So 200 kilowatt hour at 0.097273 per kilowatt hour. So this will be 200 times 0.097273. 200 times 0.097273, and that is 19.4546. Now you add everything. You have 10 plus 36.7783 plus 32.89405 plus 19.4546. Okay, what do you got, folks? So this is plus 32.89405 plus 36.7783 plus 10. And you have 99.12695. So the cost for 1200 kilowatt hour is $99.13. $99.13. and 13 cents. Okie dokie. $99.13. All right. So this is manual method or arithmetic method. Okay. But imagine you computing like this for so many customers. You have so many customers with varying amounts of power consumption. Come on. We can't do this like this. This is arithmetic. This is for 6th grade. This is 6th grade. This is the way 6th graders will do it. What is the joy of algebra? From 7th grade. That's the joy of algebra. Come on. Okay, we can't, you know, this is like killing a fly with a hammer. You want to kill a fly. Instead of you to clap your hand, like we do it in Nigeria, you know, your fly is coming, bam. You kill the fly, right? You're looking for hammer to kill a fly. So this is 6th grade way. And we are no longer in 6th grade now. So we have to do it 7th grade way. Now, so this is Herculean, it's too much. What we now have to do is we have to say, okay, hey, how can we write just functions, okay? Just one function. So I will just come in, how many kilowatt hour did you consume? 300. I put in 300, and it computes it right away. Period. One function, one. That's coming to do all this. That is the essence of algebra. Okay? Now we have been doing, all the while we have been in 6th grade. 5th and 6th, actually because magnet schools, their 6th grade starts doing algebra. So we have been in 5th grade, arithmetic. Now let's jump to 6th grade, algebra. All right, I'm going to erase this. I will erase this. And we are going to test the same thing and make sure that we got it right. If we don't get it right, that's a problem. There is a problem. If we don't get, we are going to do the second method. We've got to get it right. If we don't get it right, I hope we get it right. Okay. We fixed it. But by God's grace, we are going to get it right. Okay? We shall get it right. By God's grace. Alright, so second method is the piecewise function method. Piecewise function method, which is your algebraic method. Algebraic method. Algebraic method. Okay, so with piecewise function, just writing this like this for piecewise function, we will say, okay, that C of G, C of P, I'm sorry I said G. Maybe I was thinking of gallons in the water bill. Okay, we'll say C of P, okay, is, let's just write for the first one. Now this is 3 pieces. It's 3 pieces. Okay. Now let's write the domain for the first one. This will be 0 less than or equal to P less than or equal to 650. That is the domain for the first one. The domain for the second one will be 650 less than P less than or equal to 1000. Because this is the next 350. So 650 plus 350 is 1000. Then the domain for the third one will be P greater than 1000. So this is going to be these are the three domains for the piecewise functions. Now let us find the function that will be here, function that will be here, function that will be here. So we will let us leave this like this, okay? And let's find the functions and then we will write it well again, okay? So for the first piece, okay, we see that we must have the basic fee. The basic fee is 10 bucks. We must have it, right? And then we will now have for each one for the first piece, this will be for each power consumed, that will be P times 0.056582. And that would be what? 0.056582 P. Let me put this like this first, okay? And I will use yellow chalk. So that would be this 0.056582 P. So we now add the total cost will now be 10 plus 0.056582 P. And this is our C of P. That is for the first piece. So C of P is, let me write it first with the variable. So this is 0.056582 P plus 10. That's for the first piece. Does that make sense? Okay? Alright. The next one is the second piece. The second piece we have our basic fee. We have our basic fee, which is $10. Then we want to go through, because before we get to second piece, we must pass through the first piece. So you ask yourself, unless you're a genius, right? So you ask yourself, what is the maximum amount I can pay in the first piece, in the first tier? Okay, this is piecewise, it's in pieces. So what is the maximum amount that I can pay in the first piece, the first tier, before I now get to the second tier? Okay, so that will be 650 times 0.056582. Just, that's the maximum amount you can pay for the first piece first. For the first piece. Because before you get to the second piece, you must pass through the first piece. So 650, this is like saying the first piece first, the end point is 650. So 650 kilowatt hour at that rate, 0.05652 per kilowatt hour. And that is 650 times 0.05652. So So 650 times 0.056582. What we've just 0.056582. Yeah, this is what we just did. Okay, 36.7783. All right. So the maximum amount you can pay, for first piece, is max amount, max cost for first piece is 10 plus 36.7783. And that would be 46.7783. The maximum amount for first piece. Then before you now get to second piece, okay? So you must pay this, You must pay this first. Then plus anything remaining that falls in the second piece. So the cost here would be 46.7783 plus that rate in the second piece, 0.093983 times P minus anything remaining over 650. This is now the algebra there. Now, do you notice something? That we still have to do some arithmetic before we now get to algebra. And I tell folks this. I tell my students this all the time. Algebra came from arithmetic. If there is something you cannot do in arithmetic, you can't do it in algebra. You cannot. Algebra is from arithmetic. If you could do it in arithmetic, if you could not do it in arithmetic, okay, I'm not going to say if you could. Now, if you could not do it in arithmetic, you can't do it in algebra. So, you know, if you have something like this, x plus y all squared, okay? A common mistake some students make, I know maybe, you know, it's just like with this, they have it like this. But let's say you have maybe square root of x plus square root of 3, all squared when you have square root. And some students will write it this way, root x all squared plus root 3 all squared. Folks, think for a moment. In arithmetic, would you do 2 plus 3 all squared? Would you say it is 2 squared plus 3 squared? Just put numbers there. Arithmetic. Before you put variables, put numbers. Would you do 2 plus 3 all squared to be 2 squared plus 3 squared? Would you do it that way? No, you will not. And I'm telling everybody anyway, okay, because I have so many students. So, both those I teach in private and those I teach publicly. Okay, so it's not, if you can't do it in arithmetic, you cannot do it in algebra. You cannot. Okay, so this is like letting you know, hey, even though we are using algebraic method, we still got to do that arithmetic. We still have to pass through it. Okay, so this is the cost for that second piece. This is the maximum cost for first piece. Then anything over 650, because anything over 650 kilowatt hour falls in the second piece. So anything over it, the P, any amount of power you consume over 650 will now be charged at this rate. That is why we say this rate for the second piece times any power over 650, which is P minus 650. But first and foremost, you must pay this maximum for the first piece. Okay? So we can now finish this. This is 46.7783 7783 plus 0.093983 P minus, we distribute that 0.093983 times 650. 0.093983 times 650. So this is 61.08895. Okay, so when we do that, we now have 0.093983 P. Okay, we now subtract that. 46.7783 minus answer. Minus 14.31065. Okay. Let's cross check. Let's double check. That is 6.7783, okay, plus 10 gives you that. Then 0.093983 times 650. Yeah, 61.08895. Alright? Okay, so for 6.77. Alright, so this will be the cost for the second piece. Excuse me. So this is 0.093983 P minus 14.31065. Okie dokie. Alright. The last one will be the third piece. Then we can write our piecewise function well, and then we'll verify this again. So I need to erase this here. So for the third piece, we see the maximum for first piece. Maximum cost for first piece. First is 46.7783. Okay? Now we have to get the cost for because before we get to the third piece, we have to first of all go through the first piece, then we go through the second piece, then we go to the third piece. Okay, but you know what, before I write this maximum cost for first piece, let me not do it that way, because let's not superimpose, or let's not do something twice. Let's write it this way. Let's write it this way first. Basic fee is $10. Basic fee is $10. Then let's have the 650 excuse me, 650 kilowatt hour at 0.056582 per kilowatt hour. Okay, already we did this here, so that is 650 times 0.056582, and that gives us 36.7783. We keep that. Okay. Now we want to because we have to go through the first piece, which we have now gone through. We have to first of all pay the basic fee. Then we go through the maximum for the first piece, which we have done. Then we go through the maximum for the second piece, which we are now going to do. Okay. We do 350 kilowatt hour at 0.09393 per kilowatt hour. So this gives us 350 times 0.09393. 350 times 0.09393. 939. And that is 32.89405. Okay. So now let's get the maximum cost for second piece. Like maximum cost for because before we get to the third piece, we must find the entire cost for second piece first before we can get to the third piece. So maximum cost for second piece will be 10 basic fee plus 36.7783 plus 32.89405. And that is what? 46.7783 plus 32.89405. Mr. C, why are you wasting time? It should be the cost for $1,000. Yeah, but then I need the whole thing. I don't want to use 79.67. No. Do not round intermediate calculations. Okay, this is rounded. So we have to use the whole thing. So this is a 79.67235. I have some very smart students. If I was doing this, they would say, and they will say, that's because 1,000, you've already done it before. Okay. With mathematics, if you do it repeatedly, you know it well. All right. 79.67235. Okay. Now anything over that amount, you will now pay this price. But you must pay this first. So folks, look at the cost for this third piece. You must pay this first, 79.67235 plus anything over $1,000 kilowatt hour. I wish I had that $1,000. Anything over 1,000 kilowatt hour, you will pay 0.097273 times P minus 1,000. Okay? I shouldn't be dancing now. No. Don't dance now, no. Because you have to see whether you get it right. Don't dance yet. Okay, so this is 79.67235 plus, we distribute this 0.097273p minus 123. 97.273. Okay, so we now have 0.097 0.097273 p excuse me, minus, this will be minus, so 79.67235 minus 97.273 minus 17.60065. All right, so this will be our cost here. This is 0.097273p minus 17.60065. All right. Let us write our piecewise function, and then we check this whole thing. Then we can call it a day. Okay. By God's grace, it will work, so that I won't have to come and start editing this video and cutting it, and you know. All right. So our piecewise function will be C of P is 0.056582p plus 10. Excuse me. And that is for this here. Okay. The second one, 0.093983p minus 14.31065. Okay. Put my semicolon here. And then the last one, 0.097273p minus 17.60065 for p greater than 1000. P greater than 1000. Okay, and that's it. Now let's see. This is the piecewise function method. Let us now do everything again to verify our answers. Then we can call it a day. So number one, C of 0. Okay. So here, which piece? You see that 0 falls in this domain, so you have to use this piece. Okay? So that would be 0.056582 times 0 plus 10. And that would be 0 plus 10, and that is $10. Okay? I don't want to dance now, because this is straightforward. I mean, this first one is pretty straightforward. So I don't want to dance. Okay. Number 2, C of 300. 300 falls under which domain? First one. So that the essence of piecewise function is, you just have one function, you just enter it, and you get the answer right away, without having to go through each piece. No. like without having to go through this one. Each piece corresponds to a domain. Each piece, each function, the function in each piece corresponds to a domain. So once you get that domain, once you find what domain is it that you need, just find the corresponding function and use it, you know. So it saves time. That's number one. Number two, this is conditional statements in programming. So when you're teaching this in middle school and high school, the technology teacher, you can plan with the technology teacher so that when the students write the piecewise function, then of course in technology they are learning Python, they're learning HTML, CSS and JavaScript. With that they can even design a website and write an app right away, a web application. Or they can write Python app. They can also write a VB. They can write this app in Visual Basic as a desktop application. So that way, you know, this with conditional statements in programming is easier right away to just write it than not writing it as a formula. Okay, so this is much better. So this is for you to appreciate algebra. Okay. All right. So this falls 300 falls in the first domain. So we use this. So this is 0.056582 times 300 plus 10. So we have 0.056582 times 300, and that is 16.9746 plus 10, and that is 26.9746. 26.97. Okay. The next one, number 3. C of 1000, C of 700. 700 falls in the second domain. Second domain. So we use this linear function here. So this will be 0.093983 times 700 minus 14.31065. So 0.093983 times 700 is 65.7881 minus 14.31065 minus 14.31065, and that gives you 51.47745, and that is $51.48. See that? Just using it right away, straight on, without having to go through all those manual methods. Okay? Now, 2 more. Number 4. So let me erase this 2 here. Number 4. C of 1000. 1000 falls in the second domain. Falls in the second domain. So this is 0.093983 times 1000 minus 14.31065. So this is 1, 2, 3. 93.983 minus 14.31065. 93.983 minus 14.31065. 0.065. And that is 79.67235. $79.67. Alright, the last but not the least. Cost for 1200 kilowatt hour. So 1200 falls in the third piece. Okay. Like I said, I want you to test for each piece, both manual and piecewise. Okay. Piecewise function method. So 1200 falls in the third piece. So it falls in the third piece, in the third domain. Okay, it falls in the domain of the third piece. 1200 falls in the domain of the third piece. So we use the function for the third piece. And that is 0.097273 times 1200. Zero point 0.97273 times 1200 minus 17.60065. 0.097273 times 1200. And that is 116.7276 minus 17.60065 minus 17.60065, and that is 99.12695. Thank God, 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 thank God. Okay, folks, we have come to the end of this lesson. Please, if you have any questions, you can ask me, okay? Thank you so much for listening to this video session, and you have a great day.